In this lesson, we're exploring another way to show that triangles are congruent. We're exploring side angle side. And before we get into that, let's look at this explore activity that they have for us. And in this explore activity, they said to cut two thin strips of paper, one 3 inches long and the other at 2.5. So that's what I have here. These two pieces of paper are 3.3 inches and 2.5 inches long. And then it says, on a sheet of paper, use a straight edge to draw a horizontal line, and then arrange the 3-inch strip to form a 45-degree angle. So what I've done is I went ahead and I just built a 45-degree angle. Now the activity says to put the 3 inches up here, and then take the 2.5 and try to make as many triangles as I can out of this information, this 45-degree angle, this 3-inch segment, and this 2.5-inch segment. So very clearly we see this triangle being formed, and it's a little bit off, but you get the idea. But what you might not think to do automatically is realize that there's a whole other triangle that can be formed with this information. And so what we've realized is that having two sides and an angle does not guarantee that there's only one kind of triangle like this. However, and let's go ahead and kind of answer this question, how many different triangles can you form? We formed two. And I sure hope that you realize those two triangles are definitely not congruent. They are not the same size and shape. But if I take the 3-inch segment and bring it down here so that the 45-degree angle is the included angle between these two sides, this 3-inch side and this 2.5-inch side, if I were to connect the dots in order to make the triangle, there's only one triangle that I can make this way. So can we construct more than one triangle? No, only one triangle. And so if two triangles have two pairs of congruent corresponding sides and one pair of congruent corresponding angles, under what conditions can we conclude that the triangles must be congruent? The congruent corresponding angles must be included between the congruent corresponding sides. In the next explore activity, we're kind of justifying what we just said back here, which ends up being, the side angle side triangle congruence theorem. And they want us to do that by constructing a triangle here that is congruent to triangle ABC. And since you're going to be constructing congruent triangles, this is a good place to start. So it says we're going to do this by copying angle A, side AB, and side C. Okay, so let's start with the easy construction. Way back in Module 1, we learned how to construct a segment that is congruent to a given segment. So I've opened my compass setting to be the length of AB, and I'm going to duplicate that compass setting from D. And so what I've just identified is where the point E is going to be in my new triangle. Next, I'm going to duplicate angle A. Remember how to do that. You start with a random arc through the angle that you're copying. You duplicate that arc where your new angle will be. Then you change your compass setting. Okay, so notice here my compass setting is going to be the distance between these 2 points. So that compass setting I copy from here. Notice how my first arc and my second arc intersect. So from the vertex of the angle through that intersection, that's going to be my angle that is congruent to angle A. And now, the last thing I have to do, since I've already copied segment AB here, I've copied angle A here, now I need to copy segment AC here. So I'm going to set my compass setting to the length of AC and mark that off from this ray. So this is point F. And when I connect these dots, and perhaps some color would be helpful, this triangle is congruent to triangle ABC. In part B, it's saying that this diagram illustrates one step in a sequence of rigid motions that would map triangle DEF onto triangle ABC. So what would be the sequence of rigid motions? Well, first I would want to map DE onto AB, and I would need to do that by rotating triangle DEF around point D at an angle of the measure of angle EDB. Once I did that, the last thing I would have to do would be to reflect triangle DEF over segment AB in order to map triangle DEF onto triangle ABC. So what can I conclude about the relationship between these two triangles? Well, if a sequence of rigid motions will map one onto the other, then the triangles are congruent. So once again, we have a property that we can think of as a shortcut to determining whether two triangles are congruent. Remember, we started the module off with having to show that all 6 pairs of parts of the triangles were congruent. Now we can use 3. In the last lesson, we talked about angle side angle being 2 pairs of angles and the included side. Now we have side angle side, which is 2 pairs of sides and the included angle. So in example 1 part A, we're trying to determine whether these triangles are congruent. So I have this 20 centimeter segment being congruent to this 20 centimeter segment. I have this 19 centimeter segment congruent to this 19 centimeter segment. And since the included angles are the angles that they gave us, I notice, this 43 does not equal this 45. Therefore, the triangles are not congruent. In part B, I look for corresponding parts. JL, this 46-inch segment, corresponds to segment PM because JL equals PM, which equals 46 inches. JK corresponds to MN because the length of JK equals the length of MN, which is 74. So I have 2 pairs of corresponding congruent sides. The angles that were given to me are the included angles. So I'm going to say that angle J corresponds to angle M because the measure of angle J equals the measure of angle M, which equals 37 degrees. So two sides and the included angle of triangle JKL are congruent to two sides and the included angle of triangle, I want to name this in the correct order, M and P. So triangle JKL is congruent to triangle MNP by the side angle side triangle congruence. In this example, we're doing the exact same thing. We notice that DF is congruent to GJ. We notice that DE is congruent to GH. The angles included between those two congruent sides are marked as congruent. So, yes, triangle DEF is congruent to triangle GHJ by side angle side. Once again, in this lesson, we are proving that triangles are congruent. We're kind of getting our feet wet on using this specific theorem in order to determine whether the triangles are congruent. So in example 2, part A, I have this triangular window with two halves, and I'm trying to prove that the two halves are congruent. I am given that BD is the perpendicular bisector of segment AC, and I want to prove that the two triangles are congruent. Well, since it's given that BD is the perpendicular bisector of AC, I know that AD is going to equal CD, so let me mark them as congruent. I also know that BD is perpendicular to AC, so I know these angles are congruent right angles. And then finally, because of the reflexive property, I know that segment BD is congruent to itself, so I have this segment is congruent to itself. This segment is congruent to this segment, and then the corresponding included angles between those sides are congruent. So that's why these triangles are congruent by side angle side. In part B, we're kind of a little bit more on our own in this example. We're filling in some blanks. So it is given that CD bisects AE and AE bisects CD. So by the definition of bisector, AB and EB are equal. Similarly, DB and CB are equal. So I know that those segments are also congruent. Angle ABC is congruent to angle EBD because they are vertical angles. So, two pairs of sides and the included angle of triangle ABC are congruent to two sides and the included angle of triangle EBD. Therefore, the triangles are congruent by the side angle side triangle congruence. In this your turn, they've kind of turned us loose and asked us to complete the entire proof. So we'll have statements and reasons. The first of which would be the given, that segment AB is congruent to segment AD, and that angle 1 is congruent to angle 2. So let's take that information and put it in the diagram and kind of see where the chips fall. So this is congruent to this. This angle is congruent to this angle. And as I've said in the past, notice how the two triangles are sharing a common side. And when two triangles are sharing a common side, for example, in this diagram, they're both sharing segment AC, it is almost definite that you're going to be using the reflexive property to say that segment AC is congruent to segment AC because of the reflexive property of congruence. And now, notice I have 2 pairs of congruent sides in the triangles, along with a pair of congruent included angles. Therefore, triangle BAC is congruent to triangle DAC by side angle side.